The last thing we will look at in this section are two special types of logarithms. The first type of logarithm we'll look at is a common logarithm, and it is one where the base is 10. The reason this is referred to as the common logarithm is because we're in a decimal counting system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 digits, hence a decimal counting system. And what we do is we're just going to omit the base. So if we omit the base, that is to say, instead of writing log base 10 of x, you would just write log base x. So whenever you do not see a base, doesn't mean there isn't one, just means it's hiding. And it's very important that you always just maybe remind yourself that this is base 10. So if we apply those basic principles to what we did before, log, again, no base written here, but that just means it's 10. Log base 10 of 10, it cancels, we are left with just 1. This is 10 to the 0 technically, so this is 0. Log base 10, or just log of 10x, and notice I didn't read it as base this time, I can just say log of 10x. It's just going to be whatever the exponent is, and again, if you have 10, you still have a matching base here, means they cancel, again, just x. The other type of special logarithm is the natural logarithm. The reason it's referred to as the natural logarithm is because it shows up a lot in the natural sciences, shows up in business models dealing with interest and the like, and we'll find in calculus that it does have a lot of nice properties. Again, e is about 2.7, but is still a number, so a logarithm with base e is the natural logarithm and is denoted by ln of x. So instead of writing log base e of x, what you'll see is the ln, standing for log of natural of x. Again, this is simply read by phonetically saying each letter, ln of x, or I've also heard it referred to as ln of x. So here, in example 1, there's no base written, but ln is assumed to be log base e, so there's a cancellation here. The power on the e is 1, so that's 1. So you may actually say, okay, just maybe remind yourself this is not notationally correct, but it's just reinforcing that there's an e there. Or you may even have said, you know what, I want to be notationally correct. So you'd have log base e of e to the 1, which is also equal to e. So again, 3 ways to write it. What you'll see is this one is the common practice. So again, base e to the 1, anytime there's a 1, it's going to be 0. ln of e to the x, 1 and 2 boiled down to example 3, so that's just x. And 4, still matching bases, so it's x. So let's look at these last few examples down below. This is an example of property 4 for the common logarithm. E is our base. ln has a base e, so they'll cancel, leaving us with just 4. Notice we have an e here in the case of b, but it's not quite set up like we've been counting it. So what we could do is get a matching base. If we put e here, well, we still have to make it equivalent to our original problem. Hence we have ln of e to the negative 2.5. ln and e cancel, and we get just 2.5 as the output. Then we have ln of 3. And honestly, you'd have to use a calculator for this one. If you typed this into a calculator, you would find that you get 1.098, which makes sense if you think about e is approximately 2.7. So this input 3 is just a little bit past this, and hence this value is just a little bit past the x-intercept of 1. Okay, and then lastly, we have the composition. We have log of ln of e to the 1,000. Then we have, let's do this the inside first. Okay, ln and e cancel. So we have log, and that's still left. Then we have 1,000. And well, can I get a matching base here? Yeah, the base of this log is 10. So I can rewrite this as log 10 to the third. Then the 10 that's assumed to be here cancels. So our answer is just going to be 3.